we are going to be using the middle ordinate equation again. And just so that we have something to reference, I am going to place the middle ordinate equation up here at the top. Ri times 1 minus cosine of 28.65 times your stopping site distance. And all of that divided by R sub I. So let me give you some givens here. The first one is you have a 5-lane road with the speed on it is equal to 45 miles per hour. You have the width of the road, or the width of the lane, is equal to 12 feet. Of course, you would have known that if it wasn't given to you. And you also have the radius of the center line is equal to 1,200 feet. So what does that look like? Well, from a plan view, that looks like this. Some lanes here where you have 2 lanes going in that direction, 2 lanes going in the opposite direction, and then you have this thing called a 2-way left turn. Okay, some people call it twiddle. 2-way left turning lane. All right. If I were going to draw this from a different perspective, still the plan view, it'll look like this. One, two, three, four. Probably need one more lane here, and then we're done. Okay, where you have 2 lanes going in that direction, 2 lanes going in this direction, and then you have a 2-way left turn lane. Okay, so you have all your givens. You have your middle ordinate equation. Let's just go ahead and draw some of these givens on here. Well, we know that the center line is measured from the center of the road. This is a 5-lane road, so the center line is going to start right here in the center. All right. And the center radius from the center line reference was given to us, and it is equal to 1,200 feet. RCL, 1,200 feet. Now, what do we want to find here? Well, this was given, and so what we want to find is the closest an object can be placed to the inside lane. Okay, so that's what we want to find there, and we have everything we need to find it. So let's go ahead and do that. First thing we need to do is work with what we know. Well, we know this and we know that, so that takes care of, well, that almost takes care of your radius. All right, but some things we do still need to know. We need to figure out what our stopping site distance will be, and we can do that. We can figure that out because we know that our stopping site distance is equal to 1.47 times 2.5 times our speed, which was given to us as 45, plus 45 squared over 30 times 0.348. And since no information was given to us about upgrade or downgrade, we can just go ahead and assume that that is 0, and therefore we can get a stopping sight distance. After doing that, we determined that our stopping sight distance is going to be equal to 359.4, or just about 359.4, or 5, sorry, which we can go ahead and use 360 feet as our stopping sight distance. So that shows us that we have this taken care of so far. The only thing left is our R sub I. Now remember, as I said before, R sub I is measured from the center line of the inside lane. So that is this distance here. Okay. Next, this actually goes all the way down here. I actually kind of drew it a little bit weird. All right. But this is our R sub I. Okay. And one thing you should probably notice already from now is that our R sub I is basically RCL minus some feet. Well, how many feet? Well, we have to count it. Well, we know that this is half a lane, so that's 6. This is 12 here, and this right here is going to be 6 too. Alright, so it's going to be RCL minus 6 minus 12 minus 6, which gives us 1,176 feet. Okay. Now, if I were to plug that in to our equation now, M sub I is equal to 176 feet. 1 minus your cosine of 2.865 times 360 over R sub I again, which is 176. Then I end up getting an M sub I, or my middle ordinate, equal to about 13 feet here. So what does that tell me? That tells me that the closest an object that can be placed to the inside lane is 13 feet. Therefore, as long as there's 13 feet of clearance from any sight obstruction, the vehicles traveling in this lane are going to be able to stop in time, or at least making a maneuver, but definitely stop in time, so that in the case that there was some blockage here, they'll be able to see it and stop without having anything hindering their vision. What that also means is that if this vehicle can see it, then of course this vehicle traveling in this direction can see it. And if the inside vehicle can see it, that means all the vehicles on top of it can see it, any obstruction. So there it is. That's how you figure out what your middle ordinate is and how close you can place an object to the inside lane.